Question 2. Draw the non-zero definition region of density function of joint density function of x and y. So we know y is bigger than 1 and x in the interval from 1 over y and y. So we can easily draw it should be the shadow area is the this is the non-zero definition region of x and y, and find a question 2. Find a so that the joint fxy is a valid joint density function, and so we can know that fxy in the definition area, the interval of xy should be equal to 1, and then we can get and finally we can get that it should be from 1 to infinity log y dy, and then we can get this part should be equal to 1, and then we can get a is equal to 2, and so we can get fxy is equal to 1 power to 2 plus x over 1 over. So this is question 2. And 3. Find and draw the marginal density function of fx and fy. So fx is equal to fxy. The differential is the interval of y from the definition here, and we can know that now we need to consider the situation, the interval of x. So from this picture we can know that here is 1 1. So when x is smaller than 1 and bigger than this is the definition area of x. When x is in this interval, we can see y is in this part. Y is began at x 1 over x and to infinity. So the interval of y should be from x 1 over x to infinity fxy dy, and then we can get this part is 1 over 2, and when x is bigger than 1 and smaller and to infinity in this interval, and we can know that y is began at this part and at y equal to x, so y is from x to infinity, and we can get that it should be and then we can get is 1 over 2x power to 2, and so we can get fx x is equal to x bigger than 0 smaller than 1 is equal to in this interval. So this is fx, and also we can find fy where we can get that it should be like this. This is fy. In the same way, we can get the density function of y. Question 4. Verify x and y are valid fx and fy are valued density function. So through the definition, we can get fx x dx. The integral of x should be equal to 1, and we can calculate this part through take this fx into this formula, and then we can get it's equal to 1, so it's valid. Also for y, we also can take f of y to this formula, and we can get it's also equal to 1. So both fx and fy are valued density functions.